Okay, example 1 and 2 both involve using substitution. We have both substitution and elimination, and you're welcome to use either one. I do want you to be good at both because sometimes substitution has to be used. Sometimes elimination is much easier to use, so being able to do both is important. But there's certain problems where substitution has to be used. Other problems where elimination or substitution can be used, but elimination is much easier. So that's as far as that's concerned. Linear equations, both of them work every time. When you start changing powers, then sometimes only substitution works, sometimes elimination or substitution, but elimination is much easier. The substitution process looks like this. Solve one equation for either variable, look for a coefficient of positive or negative 1. This method right here is just above the guided practice on your sheets, by the way, so I didn't print it out on a yellow sheet. But, substitute that solution in the other equation. If substituting multiple terms, use parentheses. So if x equals two things and you change x to those two things, put parentheses around the two things. Anytime you replace one object with more than one object, parentheses go around the substitution. Simplify and solve for the variable that remains. So once you change x to some y expression, you can have a bunch of y's, solve for y. Or if you change y into an x expression, you have a bunch of x's, solve for x. Once you get that answer, use that answer to get the other answer, x and y. And once you have both of them, you write your answers in ordered pair x, y. All right, so that's what we're doing here. So use substitution to solve x equals y plus 5, 3x plus 2y equals 5. Notice this equation already has x equals everything else. That equation is already ready for substitution purposes. That x equals y plus 5 is equivalent to this x right here. So how substitution works is this. I take the bottom equation that has both x and y in it. I change this x into this expression. So 3 stays 3. I'm changing one thing x into two things y plus 5, so use parentheses around it. Plus 2y equals 5. So again, this is exactly what the bottom equation says. It still says the exact same thing. The only replacement I did was x became y plus 5. That's the substitution step. That is what allows us to be able to get an answer. All right? This has infinity answers. This has one answer. The one answer we're happening to look for is what we're going to find there. So that's really nice. Okay? If this had infinity answers, this gave us one answer we didn't care about, that would be very useful, but the one answer it gives us is what we're looking for, so that's great. So, again, all I did was y plus 5 replaced x in the equation. The equation I'm left with has only y's in it, so now it's solvable using basic algebra. Distributive property first. To simplify, I'm going to get 3y plus 15 plus 2y equals 5. And move the 15 over here. 3y plus 2y makes 5y. 5 minus 15 is negative 10. Dividing both sides by 5 gives me y equals negative 2. So I'm looking for an ordered pair, the point of intersection of these two linear graphs. All I figured out here is that y is negative 2. Okay, I'm looking for x also. So now, once I know what y equals, I've got to go back to either this equation or this equation to figure out what x equals. The easier equation to go back to is our substituting equation. Notice it says x equals y plus 5. Instead of writing y, though, I'm going to write negative 2 because that's what y equals. Substituting again. I know something about y. I'm going to take what I know about y and replace it in the equation up here. So x equals negative 2 plus 5, which means x equals 3. 3, negative 2 is the point of intersection. I write my answer as an ordered pair, x first, y second. And that's how you do substitution. Works very efficient like that. For me personally, if I'm dealing with a system of equations, if it already says x equals or y equals, I'm going to use substitution every time. Because that's going to be more efficient than elimination. All right? Again, for now, if it says in the book use substitution to solve, do that. If it says use elimination to solve, do that. Or if you just really like one more than the other, go ahead. But again, be good at both. Okay, get enough practice in both, be good at both.